With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A block of mass m is suspended from a pulley in the form of circular disc. You can see in the diagram. Mass of the pulley is m and radius is r. The system is released from rest. Find the angular velocity of the disc when the block has dropped by a height of h. Now let's do this question. First of all, see the question. Yeah, this is the diagram, and if I say this tension is acting on the pulley in downward direction, then block will be acted by tension in upward direction. Now there is no slipping at the point P and any point Q on this string, right? So if the point Q at any instant will have some velocity v, and this P will have a velocity omega r, then both two will be equal. So I will write v is equals to omega r since there is not any slipping. Right? Okay. Now let's write down the force equation on the block. You can see mg force is acting in downward direction, right? And the pulley is acted by this tension, and due to this tension torque will act on this pulley, and because of the torque angular acceleration will get generated, and because of that angular acceleration after some time this pulley will have an angular velocity, let's suppose omega, and this will have some velocity v. Now let's apply work energy theorem on the system. So we will write work done by external force is equals to change in kinetic energy. If we write the work done by the tension force, so work done by tension force on the system, right, on the system is 0, right? So the only force of which we take the work is mg. So mg is acting in downward direction on this m block, and it is said in the question, if this block moved downward by a height h, then the work done by this mg will be equals to change in translational kinetic energy of the block plus change in rotational kinetic energy of the pulley. Now if you see, the block is having a kinetic energy of half mv square, and initially it was having no kinetic energy. Now if we talk about the disc is having a kinetic energy of mr square by 2 is the moment of inertia, half into omega square. So initially it wasn't having any rotational kinetic energy, so minus 0 is also here. Now omega is equals to v by r. So I will put the value of v is equals to omega r, and this is equals to mgh. So we can cancel out this m value. So we'll write here gh is equals to half omega square r square plus this is omega square r square by 4. So you will write here 3 by 4 omega square r square. So now you can calculate this omega from this equation. You will write omega square is equals to 4 by 3 gh into r square. Now so r will be in division, right? Now if you take root both sides, you will get omega is equals to 1 by r under root of 4 by 3 gh, and this will be your answer. Simple. Now see the question again. This was our question. When the block goes down by a height h, the angular velocity of the disk was to be calculated, and we got that angular velocity equals to 1 by r under root 4 by 3 gh. Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.